Good morning, students. This is Dr. Baljeet Kaur Hundal of Department of Applied Sciences, Government Polytechnic College for Girls, Patiala, giving you a lecture on the topic Bohr's model of atom. Now, let us discuss first what all contents we will be discussing in this lecture. Before going into the details about the Bohr's model of atom, I would first discuss about the Rutherford's experiment, the electronic structure of atom, nature and characteristics of light, the various types of spectra, failure of Rutherford's model, quantum theory, and then we would discuss about the Bohr's model of atom, the success of the Bohr's model of atom, in which we will be discussing about the line spectrum of hydrogen. Then we would later on discuss about the drawbacks of Bohr's model, in which we will cover the topics, that is the de Broglie and Heisenberg's concepts. So, first of all, let us start with the Rutherford's experiment. Rutherford was a scientist. He was carrying out his alpha scattering experiments. He was doing a series of experiments. What he did, he fired alpha particles at a very thin sample of gold foil. According to Thomson's model, the alpha particles would only be slightly deflected by the gold foil. But Rutherford discovered that they were deflected through large angles and could even be reflected straight back to the source. Let us see what the experiment was, how the setup of the experiment was. Just see in that corner, we are getting it. This is the apparatus that was used. Here is the radioactive substance in the center. This is placed in a lead block, and from here a beam of alpha particles is coming. This yellow portion, this is the gold foil. This is the zinc sulfide screen, fluorescent screen. Now, when the alpha particles are striking on this gold foil, we see that the maximum particles are passing straight through the gold foil. A few particles are deflected by small angles, and a very few particles return back. They are striking the gold foil and then they are returning back. Again, another representation is there, I will tell you. See, this is the radioactive substance. This is the beam of alpha particles coming. It is striking the gold foil. Maximum particles are coming straight out of the gold foil. Then a few particles you can see here, these are deflected by small angles. Then a very few rays of particles, they are coming back. This is the maximum particles are being deflected, are getting straight through the gold foil. A few are getting deflected. Again, we are just revising it. Rutherford shot alpha particles at the gold foil. This is the lead block. This is the radioactive substance. This is the gold foil, thin gold foil. Then we have a zinc sulfide screen, the diagrammatic representation we are doing now. This radioactive substance is emitting out a ray of alpha particles. Then this is the path of the invisible alpha particles. Maximum particles are passing straight through the gold foil. A few of them are getting deflected by small angles. Then this is another zinc sulfide screen, and a very few of them are returning back. So, we see that most particles pass through, so the atom as a whole must be empty. Some positive alpha particles are deflected or bounced back. Thus, a nucleus is positive and holds most of the atom's mass. That means, since this whole portion of the atom is empty, and that is why most of the particles pass straight through the foil, and since there is a nucleus, this is the nucleus in the center. So, the particles that are touching this nucleus, they are getting deflected. These are going straight. The one that are touching the edges of the nucleus, they are getting deflected by small angles. This was Rutherford's experiment. So, on the basis of his experiment, Rutherford gave his model of atom, and he said that an atom consists of small positively charged nucleus in the center, and the whole mass of the atom is associated with the nucleus, and the nucleus is surrounded by negatively charged particles which are known as electrons, and since the atom as a whole is neutral, the number of electrons is equal to the positive charge on the nucleus. This was the Rutherford's model of atom. Now, before going into the detail about the Bohr's model, first we will just discuss the electronic structure of atom. The chemical behavior of an atom is determined by its electronic structure, and this in turn depends upon the number of electrons in an atom, the position of electrons around the nucleus, and the relative energies of the electrons around the nucleus. So, we see that the structure of atom depends upon the number of electrons, the position of electrons, and the relative energies of the electrons. Of these, the number 1 is determined by the atomic number, number of electrons. The thing position of electron and relative energy of electron, that is determined by the analysis of radiations that are being emitted or absorbed by the electrons. So, it is very important to discuss the nature and characteristics of the radiant energy. So, first we will discuss about the characteristics of the radiant energy. So, let us see now. Light is an important form of energy, and it has dual nature, both particle as well as wave nature. The waves are associated with electric as well as magnetic fields, and therefore, these are known as electromagnetic waves. And in order to characterize these waves, the various parameters that are used for studying waves are wavelength, frequency, wave number, and amplitude. So, we will discuss the wavelength, frequency, wave number, and amplitude. Let us see. Wavelength is the distance between two adjacent crests or trough in a wave, and it is denoted by lambda and is measured in angstrom. This is the wavelength, the distance between two crests. This is the crest, this is the trough, then again a crest, again a trough. So, the distance between two crests or two troughs is known as wavelength, and it is measured in terms of angstrom. 1 angstrom is equal to 10 raised to power minus 10 meters. Next, frequency. It is the number of waves or cycles which pass through a particular point. So, what is frequency? It is the number of waves or cycles which pass through a particular point, and it is denoted by nu and is measured in hertz. Hertz is the unit of frequency. Then next is velocity. Velocity is the distance travelled by a wave in 1 second, and it is denoted by c and measured in meters per second. velocity of all electromagnetic waves is same and is equal to 3 into 10 raised to power 8 meters per second. Next, wave number. It is the reciprocal of wavelength and is defined as the number of waves per meter. It is denoted by this alphabet and it is measured in centimeter minus 1 or meter minus 1. And the amplitude, it is the height of crest or depth of a trough. We will just see, this is the amplitude. It is the height of a crest or it is the depth of a trough, that is known as amplitude. This value is the amplitude. So, now let us see the various types of spectra, because before discussing the Bohrs model we should know what is spectra. When light from sun is passed through a prism, it splits up into a series of color bands. As you all might have seen the color of a Vibgyor, what we obtain in a rainbow. This pattern of colors is known as a spectrum. And depending upon the source of radiation, the spectra are of two types, emission spectrum and absorption spectrum. Emission spectrum is obtained by the emission of radiant energy by the excited atom. When an excited atom emits out radiant energy, we get emission spectra. Is it clear? Emission spectra are further of two types, a continuous spectra or a line spectra. Solar spectrum is an example of a continuous spectrum. Even the Vibgyor, the rainbow that we get, it is an example of a continuous spectrum because the different color bands are diffuse, that is they merge into one another without any separation. And in, just see, this is a white light, it is being dispersed over here in the colors of a Vibgyor when it is passed through a prism. This is a prism, this is the white light, it changes into various colors. Now, this type of a spectrum is a continuous spectrum because we cannot differentiate between the various bands, they are continuously present. Now, what is a line spectrum? In a band spectrum or a continuous spectrum, we had bands of light, and in a line spectrum, it consists of sharp lines. It is also called as fingerprint of an element because each element has its characteristic spectrum, just as each individual has its own fingerprint. Each line in the spectrum corresponds to a particular wavelength or a frequency. Later on we will be discussing about the line spectrum of hydrogen, that is why I am telling you what is a line spectrum. Now further, absorption spectrum. Emission spectrum was obtained due to emission of radiation, and absorption spectra are produced due to absorption of radiation. It consists of dark lines at certain wavelengths, and these dark lines correspond to the light radiations absorbed by the substance. So, now we will discuss the drawbacks of the Rutherford's model. Rutherford had said that we have two portions of an atom, a nuclear portion and an extranuclear portion in which we had the electrons. But this Rutherford model suffered two drawbacks. First is the instability of the atomic structure. It could not explain the stability of atomic structure, and further it could not explain the line spectrum of hydrogen. Let us see how it couldn't explain the stability of atomic structure. According to Rutherford's model, electrons are revolving around the nucleus in circular orbits, and the centrifugal force acting outwards balances the electrostatic force of attraction which acts inwards, and this prevents the electrons to fall in the nucleus. Let's see. The centrifugal force is given by the formula mv square upon r, and the electrostatic force of attraction is given by the formula Ze square upon r square, where m is the mass of the electron, v is the velocity of the electron, r is the radius of the circular orbit, E is the charge of the electron, and Z is the nuclear charge. This is the force that is acting inward. This mv square is the force acting outward. So, Rutherford said that this inward force and the outward force both balance each other, and that is why the electron keeps on revolving around the nucleus. But Maxwell was a scientist who said that charge accelerated particles lose energy constantly, and electron is a charged particle. It gets accelerated due to continuous change in the direction while moving around the nucleus. Thus, an electron must therefore emit radiation or lose energy constantly. As the electron loses energy, its orbit would become smaller and smaller, and ultimately due to the electrostatic force of attraction, the electron should fall into the nucleus. Such a collapse of atom does not take place, and hence Rutherford's model is faulty. Now, let us see the diagrammatic representation of this. This is it. According to Maxwell theory, electron is continuously revolving around the nucleus, so it should lose energy, and ultimately the path of its orbit should go on decreasing. This way it should go on decreasing, and ultimately the electron should fall into the nucleus. So, this is a great drawback of the Rutherford's model of atom. Then another drawback of Rutherford's model was that it could not explain the atomic spectra. We have seen what is a spectra, and this Rutherford's model could not explain the formation of spectras. It could not explain the line spectrum of hydrogen. According to electromagnetic theory, the frequency of a charged particle is equal to frequency of its revolution, and since the electron orbit is continuously changing, the frequency of the revolution also changes continuously. As a result, the atomic spectra of hydrogen should have been a continuous rather than line spectrum. So, we obtain a line spectrum, but according to Rutherford's model, the spectra should have been a band one. So, this is not in agreement with the observed facts. So, we will first discuss the Planck's quantum theory. Before I discuss the Bohr's model, I would first discuss the Planck's quantum theory, because Bohr took into account the quantum theory of atom. The energy is absorbed or emitted by a body discontinuously in the form of packets. Planck said that electrons or any body emits or absorbs energy in the form of packets of energy, and these packets of energy are called as photon, and the energy of photon depends upon the frequency of the radiation and is given by h nu. This is the Planck's quantum theory. Here h is the Planck's constant, and it has a value of 6.6 into 10 raised to power minus 34 joule second minus 1. A body can absorb or emit one photon of energy or some whole number multiple of it. He said that any body can absorb or emit h nu amount of energy or a whole number multiple of it. Energy less than a photon can neither be emitted nor absorbed. So, he said that always a photon of energy is emitted or absorbed. Now we will be discussing about the Bohr's model of atoms. So first we have discussed about the drawbacks of the Rutherford's model, why the Rutherford's model could not explain the line spectrum of hydrogen, and it could not explain the instability of the atomic structure. And then we have discussed about the quantum theory, the Planck's quantum theory, before discussing the Bohr's model. Now we would discuss about the Bohr's model of atom. Niels Bohr was a Danish physicist, and he proposed a theory which not only accounted for the existence of line spectrum but also suggested why atoms do not collapse. So this model could overcome the drawbacks of the Rutherford's model, that is the existence of line spectrum and why atoms do not collapse, and he modified the Rutherford's model of atom with the help of quantum theory of Planck, Max Planck. Now let us see the postulates of Bohr's theory of atom. Bohr said that an atom consists of a massive positively charged nucleus. He said that in the center of an atom there is a positively charged nucleus and the electrons are revolving around the nucleus in fixed circular orbits without radiating energy, any energy, and these non-radiating orbits are called stationary orbits. So the first postulate of Bohr's theory is that atom consists of a positively charged nucleus and the electrons revolve around the nucleus in fixed circular paths known as orbits or stationary states, because they are not radiating energy. Let us see the diagram. This central positively charged nucleus, this is an orbit, this is the second orbit. These are the orbits that Bohr has given, that electrons revolve around the nucleus in fixed circular paths known as orbits, and these orbits are numbered as 1, 2, 3, 4 from inside to outside, or they are named as K, L, M, N, O, P and so on from inside to outside. Is it clear? So the first postulate is that atom consists of a positively charged nucleus and there are circular orbits around the nucleus, fixed circular paths in which the electron revolves, and these are numbered as 1, 2, 3 and 4 from inside to outside, or KLMN from inside to outside. These energy levels are called lower and this is a higher one, still higher one and so on. So the energy levels or orbits closer to the nucleus are the lower orbits and these are the higher orbits. Then the same thing, the stationary states are also called energy level. The energy associated with different energy level increases as the distance from the nucleus increases, and because each stationary orbit is associated with definite amount of energy, the letters K, L, M, N or the numbers 1, 2, 3, 4 are used to designate the different energy levels. The energy associated with an energy level, these energy levels that we were discussing, is 2 pi square z square e raised to power 4 m upon n square h square, where this z is the atomic number, m is the mass of the electron, E is the charge on the electron, H, this H is the Planck's constant and N is the number of the orbit. So the energy associated with any energy level is given by this formula 2 pi square z square e raised to power 4 m upon n square h square. Of course, there is a negative sign over here. For hydrogen atom, the value of z is 1. So, En will be minus 2 pi square e raised to power 4 m upon n square h square. All these values are constant, 2 pi square e 4 m h square. So, the energy of hydrogen comes out to be minus 1312 upon n square kilojoules mole minus 1. This is the energy of the hydrogen atom. We can substitute the value of n. For first orbit we can substitute it as 1, for second orbit we can substitute it as 2, for third orbit as 3 and so on. Then for helium atom z is 2. So, the energy will be the energy of hydrogen into 4 because it is z square, it was z square. So, we will multiply it by 4. For lithium, it will be the energy of hydrogen into 9. The different energy levels are not equally spaced. That is, the energy difference between the two successive energy levels is not same. It goes on decreasing with the increase in value of n. Then the third postulate. Only those orbits are permitted in which the angular momentum of an electron is a whole number multiple of h upon 2 pi and is given by the relation mvr is equal to nh upon 2 pi, where n is equal to 1, 2, 3 and so on, and h is the Planck's constant. M and V are the mass and tangential velocity respectively, and r is the radius of the orbit. So, the third postulate is that only those orbits are permitted in which the angular momentum of an electron is a whole number multiple of h upon 2 pi and is given by the formula mvr is equal to nh upon 2 pi. The radius of the circular orbit is given by the formula n square h square upon 4 pi m e square, and substituting the value of h, pi, m and e, the value of r comes out to be 0.53 n square angstrom, and the velocity of electron in the nth orbit is given by 2 pi e square upon nh. The fourth postulate is that the energy is emitted or absorbed discontinuously in the form of quantas or small packets only during electron transition between two stationary states of energy E1 and E2. The frequency of the emitted or the absorbed energy is given by E2 minus E1. Let us see the diagram. This is the diagram. This is the nucleus, this is the first orbit, second, third and fourth. This postulate says that when an electron has to go from a lower orbit to a higher orbit, this is E1, this is E2, then it has to absorb energy. See, the absorbed photon, energy is absorbed. And when an electron moves from higher orbit to a lower orbit, it emits out energy. Okay? The emitted photon. Photon is being emitted. The energy is being emitted as photon, that is packet of energy. And the amount of energy emitted or the amount of energy absorbed will be given by the difference between the two energy levels. If E2 is the energy of this level and E1 is the energy of this level, so the energy that will be emitted when it moves from E2 to E1 will be E2 minus E1. So, an electron when it moves from higher orbit to lower orbit, it emits out energy. When it moves from lower to higher orbit, it will absorb energy, because same is the case when you need to jump, you need to absorb energy. So, same is the case over here, and the amount of energy emitted or absorbed will be equal to the difference in energies of the two levels. So, these are the postulates of the Bohrs model. Just let us revise again. The first postulate is that the nucleus is positively charged, the electrons revolve around the nucleus in fixed circular paths known as energy levels. These are numbered as 1, 2, 3, 4 or KLMN from inside to outside. Then second postulate is that